All right, Algebra students, let's look at Unit 6, Lesson 14, Graphs that Represent Situations. We want to look at a situation, identify a graph that's representing it, and try and figure out what's going on and where are the parts that make sense with this. I can explain how a quadratic equation and its graph relate to a situation. It's the idea of looking at the equation, looking at the graph, picking out the important distinctive parts and how those relate within a situation. So some important things that we might want to use for representing the situation are factored form, which is the form of a times x plus m times x plus n, or standard form, ax squared plus bx plus c. These are two ways that we've been writing quadratics, and so those two methods could help us with showing a situation. Then there are some parts of the graphs that may help us. The y-intercept is important, the vertex is important, and the zeros or the x-intercepts could be important. Remember, the y-intercept is where a graph crosses the y-axis. The vertex is where a graph changes from decreasing to increasing, or vice versa, goes from increasing to decreasing. And then the zeros, or the x-intercepts, are where a graph crosses or touches the x-axis. All right, so our warm-up is to look at this situation. The height in inches of a frog's jump is modeled by the equation h of t equals 60t minus 75t squared, where the time t after it jumped is measured in seconds. All right, so write that equation down and then think about what we can do with that. So find h of 0, so plug 0 in for t, find the answer. H of 0.8, plug 0.8 in for t, find the answer. Then, what do these values mean in terms of the frog's jump? So what are the seconds? What are the height? Figure those things out. How much time after it jumped did the frog reach the maximum height? Explain how you know. So find number 1, do your best to find number 2, bring your answers to class with your explanations, and then that will start our discussion. Thanks.